Human language is the most complex communication system that we have in the animal kingdom. We have communication systems that are completely innate, others that come with a little bit of learning. Then we have vocal learners such as parrots or songbirds and dolphins who can learn by imitation. But then we have the human system, and the human system is incredibly complex. It is super diverse but also dynamic. There are about 7,000 languages spoken today on this planet, and they constantly evolve, come and go. But that also means that none of these languages is really innate. Children need to learn it. And so this incredible learning affordance needs to be explained. What we know is that there's a specific genre that helps children in learning, and that's what we call child-directed speech. Child-directed speech has certain features such as specific acoustic features. It comes with a higher pitch, so if you talk to children, you usually talk in a high voice. You have a wide range of intonation. You sound nicer in a way. You repeat a lot, and this all kind of we know helps in learning and also predicts learning. You have also a common ground. You talk about a specific topic which you share with the child. The learning can happen in this shared attention. The big question that we addressed in phase one is whether this learning process in the social context where it happens is unique to humans. So what we did, we first made a broad survey on what we know about other species, and what came out there concerning this child-directed speech is that there is very little of that in other species. The only hint we found was that there is more frequent repetitions in gestural communication. It's really only humans where you have this huge amount of directedness. In phase two now, we are going to look at what are really these features, and do we find at least some other features in child-directed communications in other vocal learners?
We want to look at speech development in the infants, and we want to do it comparatively by also looking at other species that are either full-fledged vocal learners or partly vocal learners to see whether the same kind of interactions take place. We have not looked much at actually songbirds that grow up with a tutor, with an adult that potentially can sing to them and can engage in vocal communication. And for example, we know it's very comparable with infants. So songbirds, they learn their song by first babbling, so they produce these unstructured vocalizations very early on, but there's a critical sensory period in which the songbird must hear an adult, which is like the same as in humans. And then gradually over the course of several weeks, they arrive at a good copy of the song. Marmosets, they also have limited vocal learning ability, which is known as a vocal accommodation. So in vocal accommodation is when you put two marmosets together, and they will change their vocalizations slightly so they become more like each other. So this can be seen as a form of vocal learning that we also analyze now in the same context. We look at the animals as a precursor for how language might have evolved.
Within humans, we will compare neurotypical children with autistic children. We know autistic children react differently to child-directed communication than neurotypical children. And it's not quite sure yet what are the features that they do not really like so much, potentially, or what could help basically in improving then also the interaction to support their language development.